Welcome viewers, welcome to the new lesson from Dr. Arts Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon. Welcome students. In this lesson, we will be just learning about the Henderson Hasselbalch equation and how we can derive that particular equation. This part will be coming as a 4-mark question to derive the Henderson Hasselbalch equation. So it is important for you. So let us see what is actually Henderson Hasselbalch equation. Henderson Hasselbalch is actually describing or defining or deriving pH as the measure of acidity. Okay, and for that purpose he has used the pKa value, that means the negative logarithm of the acid dissociation constant. So we can just say that the Henderson-Hasselbalch equation actually try to describe pH as a measure of acidity using the pKa value, that is nothing but the negative logarithm of acid dissociation constant. So that is what actually mean by the Henderson-Hasselbalch equation. And why this particular equation is important? We have learned about pH, we have learned about buffer, etc. And in order to understand the pH and buffer system well, it will be better to learn the Henderson-Hasselbalch equation. To understand the action of buffer in different pH, it is better to learn the Henderson-Hasselbalch equation. So this particular topic is actually supporting the buffer action. So we can just see how we can derive that particular Henderson-Hasselbalch equation. So for that purpose, we can just consider a weak acid. And I am just representing the weak acid in the form of Ha. Okay, when this particular weak acid dissociates, it will be forming H plus and A minus. So it will be forming H plus and A minus. Here the H plus I have used is nothing but the hydrogen, that proton, and A minus is just representation, which is actually representing the proton acceptor or the negative ion. What is that negative ion called? Anion or cation? Everybody will be having confusion then. Anion is positive or cation is positive, or anion is negative or cation is positive. And some good students may not have that confusion, don't worry. So if you are an average, definitely you will be having confusion which is anion, which is cation. It is easy to remember, don't worry about it. We know that negative is there, so an, negative, n. So anion is nothing but the negative ions. Okay, now cation. So you can see the T, cation. So in that you can see the positive. T is the positive. Okay, so it is easy to remember anion and cation. You can just put this N with the negative and just consider T with the positive T. So anion negative, cation positive. So in that way you can just relate. So the H plus ions are cations and A minus is actually anions. Now there is another confusion, anode and cathode. What is this two? Anode and cathode. Another confusion comes. You have to keep in mind that anyway anode and cathode is nothing but the electrode which are attracting the positive and negative ions. Anion is attracted towards the anode. Cation is attracted towards the cathode. Okay, so anion we know it is negative charge. So it will be attracted always towards the positive charge only. And therefore anode will be positive. Okay, now cathode is the electrode to which cation is attracted. Okay, so as a result we can just say that cation is positive, and as a result the positive charge is attracted towards negative only. So cathode will be negative electrode. So it is easy to remember the anion, anode, cation, cathode. You must remember that particular thing. It's playing a role in your studies. So don't forget that. Now coming back to the dissociation. So we can see that a weak acid can be dissociated in this way, H plus A minus. Okay, H plus A minus. Now the acid dissociation constant Ka is actually given by the concentration of H plus into concentration of A minus divided by the acid concentration. Okay, so Ka is given by, acid dissociation constant is given by this particular thing. I am just rewriting this particular equation. I am just writing then H plus ion. So I am just deriving the Henderson Hasselbalch equation. Just follow me. So H plus is coming here. So as a result, we can see that Ka is going there, and this will be going up. Ha divided by A minus. Okay. Now I am just giving the negative logarithm on both sides. Okay. So now let us see that minus log H plus is equal to minus log Ka into Ha A minus. Okay. Now we know that this can be rewritten as log Ka into this one. So it will be minus log Ka plus log this one. So we can just say, so minus log, as the minus is there, we have to put minus also there. So minus log Ka plus, plus will be coming as a negative because it is negative log Ha divided by A minus. Okay, now we can just put this particular, we know that the minus log H plus is actually pH and minus log Ka is actually pKa, pH, pKa. Okay, so we can just revise this particular equation as pH is equal to pKa minus log Ha A minus. I just want to make this positive. So how can we rewrite pKa is equal to A plus log, I am just changing in this way, so it will be just positive then. So A minus divided by Ha. Okay, now this particular thing is actually the Henderson Hasselbalch equation, which pH is equal to pKa plus log A minus, that is anion divided by Ha from our concentration of the acid. Okay, so this is actually the Henderson Hasselbalch equation. Now I can just rewrite this particular equation as pH is equal to pKa plus log proton acceptor divided by proton donor. Proton acceptor divided by proton donor. So this is how we can derive the Henderson Hasselbalch equation. Also, you just revise the video and learn once more so that you will be understanding better. Plus, we can just revise towards the end of this particular lesson. Now, what is the importance of this particular, or what is the function of this particular Henderson Hasselbalch equation? For what purpose we can utilize this Henderson Hasselbalch equation? So let us see that. We know this particular equation. I am just leaving equation there, and the relation I am just erasing. Even though it looks somewhat easy, that is the only equation. You can just keep in mind that thing only, nothing to worry. If you remember this particular equation, you can definitely remember the function of this particular equation. It's easy. So you can find out pH. Okay, you can just find out what is pH if pKa and the molar ratio of proton donor and proton acceptor is given. Okay, so if pKa plus molar ratio given. Okay, now the same thing only, and you can find out pKa if pH and molar ratio is given. And also this equation can be used for finding the molar ratio if pH and pKa is given. So these are the three applications of Henderson Hasselbalch equation. These are for what purpose we can utilize the Henderson Hasselbalch equation. So that's about the Henderson Hasselbalch equation. So it's important you will be getting questions even for 2 mark or 4 mark to derive it and write the function of Henderson Hasselbalch equation. So far we were discussing about Henderson Hasselbalch equation. So let us revise the topic. We have already described how we can derive the equation, and what are the main functions, or what are the applications of this particular equation. We can see that Henderson Hasselbalch equation describes the derivation of pH as a measure of acidity using pKa, the negative logarithm of acid dissociation constant in biological and chemical systems. Henderson Hasselbalch equation is important for understanding buffer action and acid-base balance in the blood and tissues of vertebrates. Henderson Hasselbalch equation is derived as follows. We can just see a weak acid like HA will be dissociated to H plus and A minus as per the following equation. So we have to keep in mind about the anion, cathode, cation and the cathode. So this H plus will be the cation and A minus will be the anion. So acid dissociation constant for this particular equation is given as Ka is equal to H plus into A minus divided by HA. We can rewrite that as the H plus is equal to Ka into HA divided by A minus. And if you are just putting the negative logarithm on both sides, we can see minus log H plus is equal to minus log Ka into HA minus log Ka minus log HA divided by A minus. We can just take log H plus as the, if we are substituting log H plus as pH and pKa for log Ka, we can see that pH is equal to pKa minus log HA divided by A minus. Then we can rewrite the equation as pH is equal to pKa plus log A minus divided by HA. So the above equation is the Henderson Hasselbalch equation, and we can rewrite it further as the pH is equal to pKa plus log proton acceptor divided by proton donor. So pH will be equal to pKa if molar ratio of proton acceptor and proton donor is 1. Okay, so if the molar ratio with proton acceptor and proton donor is 1, it will be equal to pH, and we can say that it will be at the equilibrium. Now Henderson Hasselbalch equation allows to calculate pKa if pH and molar ratio is given, calculate pH if pKa and the molar ratio pKa, the first one pKa if pH and the molar ratio is given, and the second one pH if pKa and molar ratio is given, and third one molar ratio can be found if pK and pH is given. So for example, if a solution contains 1 molar solution, 1 molar sodium acetate and 1 molar acetic acid with pKa being 4.73 at room temperature, the pH of the solution will be calculated as follows. We can find out it will be 4.73 as in the equation that is given there.